Gonna leave all that chocolate up there in front of me. All right, so I'm gonna kind of have a more traditional kind of research-based talk today to kind of show you some of the ways that I've been thinking about recreation and impacts to wildlife. And this is some work that I did with some collaborators, so I want to make sure I acknowledge them. Kevin Gutzweiler at Baylor University and Dr. Chris Mons at Utah State University both kind of helped with this effort. So when I initially gave this talk, the first time I gave it was at ESA, Ecological Society of America, and I wanted to make sure I kind of defined my field to folks there. So you might not need this definition, but I left it in anyways. So I identify as a recreation ecologist. So my field of research looks at trying to understand the environmental consequences of outdoor recreation and other nature-based recreational activities, and how we can manage, mitigate these effects, and kind of balance these two things. So the types of recreation impacts the recreation ecologists look at aren't just wildlife related. Some of my research is also focused on impacts that you see on the ground to vegetation and soils. And these can be kind of impacts that we can see on the ground that can give us an indicator of where recreationists are going as well. So keep that in mind when I start showing you some of the results and some of the maps. My work looks at recreation use patterns, and sometimes we're either measuring the recreationists themselves, or sometimes we're measuring the impacts as those recreationists leave on the ground as an indicator of where they've been, and in particular maybe where they've been off trail. So how do I measure recreation disturbance? The main method that I use, and I think you'll see a couple other talks today looking at this method as well, is using GPS and GIS technology. So the photo that is on your left, you can kind of see a little yellow tag on that gentleman's backpack. That's a small GPS unit that we have given this recreationist to kind of see exactly where they went during their recreational activity. Some of the other disturbances, like I showed you photos of, impacts on the ground, like visitor-created trails, visitor sites where folks are standing at a view shed and creating impacts to vegetation and soils. Those we can also map using high-accuracy GPS units to kind of figure out where those are on the landscape, get a measure of the extent and the level of impact that we see. So it's a little hard to see, but this is a map of just basic GPS tracking data from recreationists in Yosemite National Park. So most of my work to date has occurred in the Park Service, so you'll see a lot of national park examples, but the methods and ideas that I present can be applied to any public land where we have recreation use. So all those little blue dots are different recreationists that have hiked off trail on this meadow in Yosemite National Park, and you can start to see patterns of use. You can see where most of the use is occurring, and if you look at kind of the western side of this meadow, you can see very little use happening there, right? So these patterns can help us begin to understand where we might see recreation impacts to either vegetation, soils, or wildlife. I mentioned that I also work in research where we map the impacts on the ground to get the level and extent of those impacts. So Mike was talking about kind of we can see where visitor trails are and those point locations. This is kind of how I operationalize that, how I map that. So this is a lake in Rocky Mountain National Park, and all that spaghetti kind of pink lines, those are all visitor-created impacts. Those are visitor-created trails where visitors have hiked off trail and created impacts. The little dots that are probably a little hard for you to see here, but those are locations where visitors have created kind of sites on the ground. This is a popular bouldering area, so another kind of emergent activity. So most of these trails and sites are generated from visitors seeking out rocks to boulder on. So this is kind of the base data that I have that look at outdoor recreation and recreation impacts. So where people go and kind of the impacts they leave on the ground. And so as a recreation ecologist, I was starting to think about, okay, we're really good at measuring impacts to vegetation and soil, right? The plants don't move. We can go out, we can see the impacts in the ground. As a field, we haven't done the best job starting to understand the impacts to wildlife. So this paper was mentioned earlier, this paper by Larson et al. That was a meta-analysis looking at the impacts to recreation to wildlife as a whole. And Mike already talked about kind of some of the ideas that came out of that, and the general idea that recreation impacts are pretty widespread, and we see impacts from motorized and non-motorized use. Not too long after that paper came out, another meta-analysis came out that said the exact opposite. that the negative impacts to wildlife were over-reported. And they defined recreation a little more broadly in this paper. I will give that caveat. They included tourism as well. But their point was that, we really often just report the negative things we see, and we might be kind of overemphasizing how negative the impacts are to recreation. So my main takeaway from this was like, okay, well, we aren't very good at measuring the impacts that recreation has to wildlife. And so as a researcher, I was trying to think, okay, well, how might we make this better? How might we approach this differently? And one of the things I started thinking about was this issue of scale. So when national parks or other public land management agencies come to me to help them look at a recreation issue or a recreation impact, we're often thinking about the scale of a single recreation site. So this photo on the left is a lakeshore in Grand Teton National Park. There's a study I have going on now, and they are really concerned about impacts on the edge of that lakeshore. Now, spatially, in the scale of Grand Teton National Park, that's a relatively small area, right? That's not necessarily the same scale that the wildlife species in Grand Teton National Park are experiencing that lake, right? So the scale that we think about recreation impacts might be slightly mismatched from the scale that wildlife species are using that landscape, or the scale that they're interacting with the recreationists at. So the research question that myself and Kevin and Chris came to is, can we borrow tools from other fields, from landscape ecology, from wildlife science, to kind of better incorporate wildlife data into some of this recreation use data that we already have and we know how to analyze? And so what we did is to start to think about these recreation disturbance measures that we have, the GPS tracking points from visitors, the maps of social trails on the ground or other impacts, and think about them as an attribute to the landscape, almost as kind of a different habitat type, a disturbed type of habitat. And so we were able to take these measures and create maps of recreation disturbance at low, medium, and high levels. We did put them into categorical variables for this methodological paper to kind of show how we might do this. And we did that for both the GPS tracking points, showing where visitors actually went, as well as for some of those resource impacts data that I had, those informal trails. And then we took a lot of different metrics from the field of landscape ecology and tried to understand the patterns of use on the landscape. So we did some really basic analysis in GIS, and go through this part quickly, where we just looked at how much of the landscape is impacted. We used the program FragStats, which is, looks at kind of different patches of habitat type, and we treated, again, recreation as a different kind of habitat patch to look at the number of patches and how far apart those patches were from each other in the landscape. Again, to understand patterns of recreation impact and use at the landscape scale. And then finally, we use the program Cone4 that allows you to understand habitat connectivity and use recreation disturbance as kind of something that could kind of pull that habitat type out and see what that did to connectivity. So assuming that recreation disturbance might be making that habitat unsuitable for particular wildlife species, and what does that do to habitat connectivity? So I kind of broke this down into kind of 4 lessons or 4 takeaways from this analysis. So when we look at some of these broader spatial scales, the scale of an entire watershed or a corridor in a national park, and again, this data comes from various national parks, we found that the recreation disturbance at these broader spatial scales made up a fairly small percent of the total area. So here on the left, we have a map from Rocky Mountain National Park and the Bear Lake Road Corridor. If anyone's been there, it's a very popular destination in the park. Some of their heaviest use levels is here. And we found that at kind of this broader watershed scale, recreation use really only impacted between 1.5% and 2% of the landscape. If we look at the patterns of informal trails on the bottom right, we saw more closer to about 14 to 15% of the landscape that was impacted by those informal trails, right, by impacts on the ground, vegetation loss, compacted soil. The second lesson we learned was that there might be some places in the landscape where wildlife can kind of get away from recreation disturbance if they need to. So unfortunately, none of us are wildlife biologists. We didn't have actually wildlife data, so if some of you want to talk to me about doing that, let me know. But we did create some hypothetical kind of sampling locations on the landscape where we might want to look at a particular nesting location of a species, or you could put kind of home range maps on here, and try to see how patterns of recreation might influence those sampling locations. So what we found is that if we had imagined maybe 4 hypothetical nesting locations for some type of bird species, A and D had very little exposure to recreation use, and even C here on the top kind of right corner of the map, that particular location, even at those kind of broader rings, only had about 7 to 8% of that habitat influenced by recreation disturbance. Now it's important to note that that recreation disturbance was at a high level, but again, we're just trying to show methods and ways to incorporate some of these recreation use data that we collect with wildlife data. Now, lastly, one of our other main takeaways was that the location of the recreation disturbance is incredibly important for the level of impact. This probably makes sense, but at one of our recreation sites where we had GPS tracking data from visitors was a mountain summit in Acadia National Park in Maine. If you know much about mountain summits on the East Coast, these above treeline habitats are very rare. There's not very much of them on the East Coast, and so this is an incredibly sensitive habitat system. It's basically alpine tundra that could be particularly important to different species. Recreation disturbance took up pretty much the entire extent of this limited habitat, right? So here, even though a fairly small percentage of the area was impacted with low recreation use, that light yellow, about 14 to 15% was impacted by high or medium, and that took up the almost entire extent of that very key habitat type, okay? So even though in some situations the total percentage of the area impacted by recreation may seem relatively small, it's important to look at where that percentage is in terms of habitat types. And then that analysis where we looked at patterns of recreation disturbance and how they influenced habitat connectivity, that Cone 4 analysis. To do this, we took that same map that I showed you from Rocky Mountain National Park, where we had recreation disturbance impacting between 1.5% to 2% of the overall area. And we overlaid it with a habitat of grass and mixed grass and forb. Again, this was a hypothetical exercise. And we took habitat patches where recreation kind of bisected that habitat out of that habitat mosaic, right? Just assuming that if it was disturbed by recreation use, then it might no longer be suitable for particular wildlife species, and tried to see what that did to the overall habitat connectivity. So only 4% of the patches, those are shown in that kind of hot pink color, were actually impacted by recreation use, but that resulted in an 11 to 12% reduction in habitat connectivity. Okay, so again, these patterns on the landscape, even if we're not seeing a lot of recreation use, where that use is happening is incredibly important when we're thinking about impacts to wildlife. So my goal here today was just to kind of demonstrate some of the methods and some of the ways we're thinking about this potential scale mismatch between the way we measure recreation and the way we think about and measure wildlife species. I'm sure there'll be some other presentations today that also kind of think about this idea of scale. So some of the takeaways from this is that when we're starting to understand recreation use, thinking about what scale is not just important for the recreationist, but what is the scale we should be thinking about that's most relevant for any potential species that could be impacted there. So the scale of analysis for a butterfly species, for example, is going to be much different from the scale of analysis that we might need for a large predator. We also need to think about what other variables or interactions are important for thinking about wildlife. So there's another future direction. And then trying to think of ways that we can bring this together into more meaningful and predictive models that are important for managers. So my main take-home messages, I teach a lot of classes here, so I also end with take-home messages for the day. So if you only remember 3 things, here you go, here's your 3 things. So we have some tools and approaches, both within the field of recreation ecology and from the wildlife sciences, to understand recreation disturbance at larger spatial scales. But often these folks aren't necessarily talking to each other, right? We already discussed a little bit about how sometimes social scientists are talking to the wildlife scientists. Same thing here. How can we come together and try to solve these problems together as a team? And then lastly, thinking about issues of scale have really important management implications. And so understanding, again, by working together to figure out what scale is most important for managing recreation and understanding recreation, and figuring out if that is the same scale we need to be thinking about when we're thinking about impacts to wildlife from recreation use in our parks and protected areas. So that's all I have. I'll take any questions. that you might have. I think I have time. I usually talk pretty fast. And thank you so much for your attention.
Questions for Ashley?
Yeah, Eric.
Yeah, so on the user-created trails that have a larger impact area, do you think that's because maybe at times there's less defined trails, people are wandering around, and I'm quite sure. Do you have any ideas of why there's that bigger footprint?
Yeah. So the question was if I have any idea why there was a bigger footprint from the informal trails than there was from kind of the GPS tracking. And yeah, it is folks wandering off trail. In these locations that I work at, they're very a lot of them are very front country national park locations, so the designated trail is very established. So most of the time in these situations, it's visitors seeking something else. So they want to get close to the water. That was a big thing in the example I showed you. That site, water was a big feature that folks wanted to get closer to, and if the trail didn't take them near that waterfall or near that river, they made their own trails to get there. And so in that case, it's not always necessarily folks don't know where the designated trail is, but there's some other experience that they're seeking that the designated trail might not be providing for them. Does that answer your question?
That wasn't the answer, but you did answer it.
Okay. Any other questions? Yes.
This may be too long of an answer, so just say so if you can. But you were speaking about connectivity, and that through the modeling, there was like a 16% decrease. Can you just give a little bit on how that was measured?
Yeah, so the question was about the connectivity modeling. So the program that I used Cone for, basically, I should have given a little more background, but you create a hypothetical species that has some distance that it can disperse, and a dispersion probability that you build into the model, and so it takes that into account. So in the model, I took like a large ungulate and used kind of averages from the literature to model that, and then also like a small rodent, basically. So the paper has two different models. Good question. But Cone 4 has all that information in it. Yeah. Good. Awesome. Thanks so much.